Our next speaker is the chief scientist at Anyscale, and as Sudhir mentioned, we are in mile one. Many of us are running experiments, figuring out how to use LLMs and foundation models. Many design patterns are emerging. Even simple systems like retrieval augmented generation, there's a lot of knobs to turn, right? So what's my chunking strategy? What embedding model should I use? What vector database is best? What information retrieval algorithm should I use? Should I use a hybrid of BM25 and some nearest neighbor algorithm? So the point is we're in a very experimental phase of using foundation models. And our next speaker is my go-to resource for some of these very empirically driven design patterns. He has published a lot of blog posts that I recommend, which you can find at anyscale.com/blog. And he's here today to tell us some more of his findings as he experiments and uses large language models at scale. So please welcome Waleed Kadous of Anyscale.
Thank you very much, Ben. I'm very grateful for that introduction. So let's get right into it. Okay, so my key points here, because you might want to go ask Sudhir, and so I wanted to give you kind of a preview of what I'm going to talk about. My goal here today is to give you some patterns for LLM applications that you can apply within your own company, within your own context. So if you leave here and go, yeah, that matches this particular pattern, hopefully that's helped you to work out how to apply LLMs in your domain. So roughly the patterns we're going to be looking at are summarization, because that's kind of the easiest one to do. The second one is the family of RAG applications. There's actually not just one. And then the third collection is in-context assistance. And that is perhaps the most complex, but also potentially the most rewarding. And then finally, I have a bit of bonus material that I've put together because the talks today have been so interesting. I had some thoughts on Professor Dr. Nguyen's presentation, and then I'll just share some heuristics I've learned the hard way. Cool. So I come from a company called Anyscale. I'm not trying to plug it. I'm just trying to explain what we do. And we are the company behind a very popular open source project called Ray. Ray allows you to build scalable AI systems. And scalable means in this context that you can run lots of nodes, you can keep resources cheap, and you can do it in a fault-tolerant, highly available way. So we're used by a lot of LLM companies like OpenAI and Cohere to train their models. Because when you're training a model and you need 1,000 GPUs running for 2 months, you need a lot of robustness, reliability, and performance. So ChatGPT and GPT-4, GPT 3.5 Turbo, all of those were trained using Ray. Not only that, but there's a wide variety of customers that are using Ray to build their systems, so that if you've used any of these products, there's a good chance that you've used Ray or benefited from the machine learning that runs on top of Ray. So our experience with LLMs comes from 3 areas. Number one, we actually serve LLMs to users. So you can come, you give us your credit card, and just like you use ChatGPT or use the OpenAI API, we charge you per token. Secondly, we have used LLMs ourselves to make our products better. And thirdly, we've helped our customers to use LLMs. So through those set of things, we've learned a few, I would say, painful heuristics and a few patterns about how things work. So just to go through those things very quickly, the first thing we offer is a product called Anyscale Endpoints. And that is just like a pay-per-token model. So if you want to use one of the open source models like Llama 2, you give us your credit card and you pay a very, very reasonable price of $1 per million tokens to use Llama 2 70B. Not only that, but we also make it possible for you to run LLMs inside your own cloud. So if you have an AWS cloud, you give us limited AWS credentials, and we'll run the machines for you, manage all of those expensive A100 and A10G nodes. You just tell us, I want to run this model, and we'll take care of it for you. And the third thing is that we have a very rich platform called the Anyscale AI platform. And this is allows you to manage clusters, gives you an IDE, gives you all of that really cool stuff. And all of these systems are built on top of the open source Ray libraries. So let's talk about the first of these applications or use case patterns that I see. And that is summarization. It was really funny what happened when GPT-3 came out is that there had been these systems that did summarizing that were very carefully engineered end-to-end and all this kind of stuff. And then what happened is you can just use LLMs pretty much straight out of the box to give a summary. And it works surprisingly well. So at one point we were considering having a summarization endpoint, but it turns out there's nothing there because it's just like you tweak the prompt and it doesn't do too badly. So all you do is you kind of give the document into the system and you say, please summarize this into a certain number of bullet points, ask it to stick to the facts, tell it to drop the irrelevant part, and optionally, what you can do is you can have a bit more of a aspect-oriented summary. I want you to focus on summarizing the complex legal issues that are covered in this topic or whatever else. And so as you think about your domain and your companies and your industries that you're in, here are some of the possible areas where you can apply summaries, right? You can use it to summarize research papers. You can use it to summarize business contracts. You can use it to read very long 400-page quality reports and pick out the information that's most important for you. These are some real things that you can do today with summarizing, and it's about one of the easiest use cases for LLMs that you can do. So I want to give you an example of a customer that we have. This is a startup called Merlin, and they are a little Chrome plugin that goes in the top right-hand corner, and then it kind of creates this little panel on the side. So I can get to this web page, like I was looking at the K-First web page. I can click a button on summary, and it will then summarize the page for me. And it can provide answers based on that summary as well. So you know, it's a way of reducing the amount of information we have to serve. And Merlin uses us for summarization because it's cost effective. They use the Llama 7B model. And it's about 5 to times 8 cheaper. And because, again, you know, the revenue models are a little bit weird for these kinds of examples. But that's one example that uses summarization. One thing to be very, very careful about summarization is amongst the use cases you can use LLMs for, it is one of the most expensive. And that's because feeding in all of that data, say you have a 100-page document with, say, 20,000 words, let's say, well, that's about 30,000 tokens. That's like $6 or $7 or whatever else, right? So here's a real comparison that we did. We looked at summarizing using GPT-4 versus summarizing using an open source model called Llama 270. So this is a model that you can download for free. If you happen to have a $75,000 machine, you can run it. But we take care of running that for you. And the key thing to notice here is that if you want to use GPT-4, it costs about $6 to summarize one 100,000-word document. Whereas with something like Llama 270, it costs about 19 cents. Now, you might say, why not just use GPT 3.5 Turbo? That's nice. It comes from a company. It's not like some half-baked open source thing. You know, you might say that. I don't think that's fair to open source models, but we'll leave that for another time. And the answer is, believe it or not, because the open source model is better than GPT 3.5 Turbo. So here's an example. When you're summarizing, one of the trickiest problems that you have to deal with is making sure that the summary is factual. So one of the ways that in the academic world they've used this is they've said, can you tell the difference between two statements that are both summaries of a paragraph and tell me which one is factually correct, right? So this is some statement about a politician, and one of them suggests that people are fitting in between Miliband's ears. That's obviously an incorrect summary, right? So only the first one is a correct summary. So now we actually do this evaluation to determine which of the LLMs is more factually accurate. And sure enough, you can see humans perform at about 84%. GPT-4, you know, is slightly better than human. That could just be noise. And Llama 270B is just slightly behind at 82%. But GPT 3.5 Turbo is considerably worse at 67%. So here's an example where you might want to use an open source model for summarizing because it's cost effective, but also because it's factually accurate. So the point here is that cheaper is not always worse. You really have to think a lot about the cost of computation with LLMs. And those costs can be considerable. The other thing to realize is models have this thing called the window size. It's called the context window size. So you can't just take like a 100,000 word document and feed it into almost any LLM. That's just going to exceed its context window. So you have to split the document into little pieces and glue them together. But there's also a slightly less popular model than OpenAI's, which is called, from a company called Anthropic, called Claude 2. And that allows for a 100,000 token context window. Now, that's very useful for these summarization tasks. And if you're prototyping, I would recommend that you use them. If you want to do that kind of split and merge thing, there's a very popular toolkit called LangChain that already does summarization in a very convenient way. So you don't have to deal with this. You need to just use LangChain to help you with the summarization. So now let's talk a little bit about what I see as the retrieval augmented generation family. I don't see RAG as one solution. I see it as a set of 4 solutions which we'll go through. And I wanted to emphasize this for this audience because I think one particular instance of RAG is one that I'd like you to think about in your context in industry. So the first thing to realize is it really is there to solve 2 problems that happen with LLMs. Firstly, LLMs don't know everything. They're not trained on your data. And secondly, LLMs have a tendency to hallucinate. So what if we can augment the input to the LLM with information that comes from another source? That source might be a vector database, it might be an internal company wiki, it could be any of these things. But all of them basically are about augmenting the input to the LLM with data that comes from a secondary source. So the way that I see it is that there's really 2 axes here for those 4 different flavors. The first one is what is the input that you want to use? What is the input source? So it could be that you have data ahead of time that you want to index. So think about a customer support application. Or it could be that you have documents that you've just received 2 seconds ago that you want to process. So the 2 axes here are like, what is the source of the data? Is it text or, what is the source of the input? Is it text or data? And the other axis is this something you've had a chance to do before? Or is this something that's coming in at real time? So I'm going to talk about, the one that most people talk about is the knowledge-based QA one, this one in the top left-hand corner. And that basically comes down to this type of setup. And I'm sorry that the slides aren't coming clearly. But the first stage is a pre-indexing stage. So imagine that you have a bunch of HTML files that describe how to use your product. You're going to load the files in, you're going to cut them into tiny little chunks. We do what's called embedding. Embedding means converting a bunch of text to a vector that you can store in a database. So this is the pre-indexing step. This is the bit we do before we use the LLM. And then what you can do is you can use that index to kind of do almost like a mini search engine. So when someone puts in a request, you have the query that gives you, you then apply the same embedding that you did before. You do similarity with the other things that we constructed in the vector database, and you retrieve the best results. So that would be like a mini search engine that we kind of built using semantic indexing. Now all you do is you kind of take that flow and you stick this little bit at the end that basically takes that output from what have been the search engine, generates a prompt, and gives you the response. So for example, the quest is, what's the difference between these 2 features of Ray? It will then give you text, but the text didn't come from nowhere. It came from data that we pulled out of the vector database that we had before. So some great examples of knowledge QA type applications or knowledge-based RAG is things like a customer support application, internal company knowledge chatbot, searching your databases, whatever it is, and also technical documentation. So to be concrete about it, if you now go to docs.ray.io, there's a little button at the bottom there that says ask.ai. You click on that, and the system that you get back is a RAG application. We've taken all of our Ray documentation, all of our bugs, all of that kind of stuff, and we've put them into a database so that if someone asks you a question, ask a question about using Ray or Anyscale, we can give them an answer that's very accurate. And we're really proud of this system, like it's surprisingly good. The other thing with these type of RAG knowledge QA applications is because they are of the simplest types of LLM application, is that they've been tested in industrial contexts. So there's a professor here at Stanford, his name is Eric Brynjolfsson, I hope I said that right. And he introduced a RAG-based customer support system into a Fortune 500 company. And they had more than 5,000 customer support agents. And what he was able to do was measure the difference between before and after. And what they found is that there was a 14% increase in resolved customer issues per hour. 14%. Simply by adding a RAG-based application that made all of that customer documentation more easily accessible. That's huge. I mean, a lot of you have industrial processes. You would kill for a 14% gain in productivity. And then the other thing is, it really helped to level the playing field because it gave like the more low-skilled workers access to information that people previously had only had through experience. So it really leveled the playing field and made the poorest performers even better. And that was one of the interesting trends. I really recommend you read this paper. It's a really great paper. So thanks for that. So here's kind of like what I would summarize as the lessons for these knowledge-based QA approaches. The first one is, if you already have a knowledge base, this is an easy thing to fix and to do. But the tricky thing to get right is the search results. Making sure that whatever vector search you do or database search gives you good answers. Because LLMs, if you feed them garbage, they'll spit out garbage. So you have to make sure that the search results are really good. That's a bit tricky, so you might want to look to startups. One example startup is Glean, so that will index all of the documents in your company and make them available through a conversational agent. And the other thing is you don't need like GPT-4, Llama 2, or GPT 3.5 Turbo is fine for RAG applications most of the time. So the next one is basically almost a variant of that, except that instead of having time to pre-index the document, you just get presented with the document. You're working in a law firm, someone gives you a contract, they want you to check the contract in the next hour, maybe you're working in the legal department. The main difference is that we haven't seen the document before. This is still one of the more cutting edge areas, and honestly, I'm in the middle of a blog post on this comparing 3 essentially different approaches. One is to convert it to a RAG job. The second one is you take the entire document and throw it at Claude because of its large context window. And the third one is chunking it up into little paragraphs and asking, does each check section of the document help you to answer a particular question? The third flavor of this is what you might call talk to data. So before we were processing text, right? It was things like contracts or like internal wiki pages or PDFs and stuff like that. So one of the more interesting applications is taking data that you have within your company, like stored in a SQL database, and providing an interface to it so that you can get results back. So usually what happens there is that you translate natural language to SQL or similar. Now, you have to be very careful when you allow an LLM to generate SQL. And the reason for this is something called SQL injection attacks. So this is one of my favorite XKCD comics. It's a woman who called her son, Robert, quote, dash, drop table students, and thus nuked the students' database at the company. Because you have to make sure that you sanitize the output that you feed to SQL. One of the things that Dr. Nguyen talked about is really this idea of fine-tuned models can outperform large models when it comes to talking to data and for these types of applications. And I want to give you an example of this, right? So you can imagine that really what we're trying to do here is take something that's like natural language and convert it to SQL. And that is a very fixed format task, right? So imagine you have human input at the top, you get some idea about the structure of the data, and then and the output you want to produce is something that you can hit your SQL database with. So here's what happened. We took a small model, Llama 2 7B. This is a model that's small enough to run on your consumer level GPU if you have an RTX 4090. And what we did is we used a process called fine-tuning to train it on examples of converting from natural language to SQL. And initially, it was a complete failure, 3%. But after fine-tuning, it achieved an accuracy of 86%. And that was more accurate than GPT-4 on the same task, even though it cost about 1/300th the price. The next one of these type of family of RAG applications is really this talk to data. But instead of it being talking to data that's living in a SQL database, you're talking to a living system. So a good example of this is imagine that you have a factory and you have a digital twin representation, and you want to provide a text interface to your natural language, to the system that's running. You know, why is cooling tower 4 running hot? Oh, because blah, 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 output, whatever, right? So a good example of this is, you know, you might ask something like, are any parts of the system seeing Wi-Fi congestion? And it'd be great if the system could come back and say, hey, actually level 7's having some issues. I noticed that a lot of people are hopping on the guest Wi-Fi network. Maybe you should check that out and see if there's a conference happening or something like that, right? So the way that you do that, basically, is you define functions for querying the state of your system. So you will have some interface for accessing information in a technical way that you could apply to your system. And then basically what you do is you build a system that translates queries into those functions. So this is a company I know about from Australia. It's called OverIP. And what they do is they have a traditional technology stack that monitors IT infrastructure. And they've built a system called Expertly that exposes the same information that might be on a dashboard or might be displayed in a lot of graphs, but makes it accessible through natural language so that it can be used as a debugging tool. So this is like using natural language and LLMs as a sequel to databases. So let's just pause, see where we are right now. We've talked about two patterns in general, right? One is the summarization pattern. The second one is like 4 variants within the RAG pattern. And then this is the last section, which is in some ways the most impactful and the most interesting and the most courageous, but it's really hard to do. So a good example here is, you know, these are tools that work with you as long, you know, as you are building your system. It might be that you're building electronic design automation tools or something, right? And this is a tool that lives there and you use it. It analyzes the context and it will provide suggestions for you. So a good example is smart code completion. So who here has used GitHub Copilot or knows what GitHub Copilot is, right? That thing is like amazingly good. If you've used it, if you haven't used it and you're a programmer, you owe it to yourself to try this thing out. What's more is that there was a randomized controlled trial and it showed, so GitHub Copilot is this system where you kind of mix together inputs from, it looks at your code and makes suggestions for, it's like autocomplete on like complete steroids. And it allowed, you know, these results are pretty amazing, made developers 55% faster, and it allowed them to focus on more interesting work. And another example is something we built called Anyscale Doctor. And that's an internal diagnostic tool. So I mentioned before that we have a thing called Anyscale Platform, and in that we have a Jupyter Notebook. Now, at the bottom there, let's say you put import requests and you try to install it, and you forgot to install, you try to run it, you forgot to install requests. So this system, you click on Anyscale Doctor, and it will go through and install it for you. But what if it's something more complicated, like, you know, there's lots of logs and so on that are going on? You can see that, you know, we have Anyscale Doctor. You click on that button, it reads the logs for you, it realizes that you made an error, you didn't request enough GPUs for this job, and then it says you should modify this file to fix this problem. So these are really great examples of in-context assistant for your workers, your engineers. I think that's another great case. So these are kind of at the trickier end of the spectrum to build, but it requires quite a lot of fine-tuning. And that's planned for us to deploy this into our product in the next week or two. One interesting pattern here is that it's not just one LLM call. There's like multiple stages of LLMs calls that we use. And we use different LLM for different purposes. If one is a code-related LLM, we'll use an LLM that's fine-tuned for dealing with code. So I want to spend the last few minutes here. I had some thoughts on Dr. Nguyen's talk. And I just wanted to clear my bias here that I'm clearly on the Silicon Valley side of that conversation. And And the first thing I want to emphasize is I know there's a lot of sexiness and discussion about SSMs, but I think it's really important to understand that it's not either or. It's like which one of these two tools is more suitable for our particular use case. And even GPT-4 and similar use cases can be used as really, really great prototyping use case, prototyping tools, evaluation tools. It's not just the production system. So don't kind of necessarily think about either or, but think about options, right? And I gave an example earlier that we actually use an SSM for a natural language to SQL conversion. The second thing is we are hearing a lot from companies about AI sovereignty, not just countries, but companies who are not comfortable sharing their data with other places. And that's something that we definitely see. I found the division between digital and physical businesses a little bit confusing. And I think we're moving towards a world where those two things are mixing together. And like I gave examples, I worked at Uber, Waymo. These are examples of companies that are clearly mixing together the digital and physical world. And then the last one, and this is maybe the most controversial, and again, I want to be clear, this is not an attack in any way on the demo that we saw of Ava, but it's really important not to underestimate GPT-4. So I took the same questions that Ava had, and I asked them, you know, a pick weighs 425 kilograms. How many people does it take to carry it? And sure enough, it spits out 19. And again, I'm just trying to show what GPT-4 is capable of, because it's just freaking amazing, right? I asked the second question, and to my surprise, it found like an error in Ava, which is, of course, the number can't be $1,125 because each person's $150. So it gives the correct answer of $1,050. So it found an error in Ava. And then the last thing is I asked it is, in an MRI machine, what might cause a low pressure alert? And number one cause is helium depletion, right? So GPT-4, do not underestimate it. It's very capable, but there's still reasons to use Ava, including safety and so on. But GPT-4 is a very, very capable system. I'm going to skip my hard-won heuristics. I can share the slides after, so you can read these, but I know we're out of time, so I'm going to go ahead. And just here are the key summaries that I wanted to share. We've seen these types of patterns before: summarization, RAG, and in-context assistance. I really want you to remember those three patterns so that when you go out into your companies and try and, can I use LLMs here? Those are the spaces that you can use them in. And with that, thank you very much. I'll be outside to answer questions. My email address is mwk@anyscale.com. And you can find out more about endpoints or any of the other products that we had from these details. And thank you very much. Do we have